Welcome back. Today we're going to be solving one-step inequalities. So I first just want to touch on what's the one difference between solving equations and solving inequalities in terms of how we actually go about solving, is that we're going to be solving them the same way, except whenever we multiply or divide a negative sign through the inequality, we must flip the inequality. Now, what do I mean by that? I mean that when we multiply or divide a negative sign through, if the original sign was greater than, we would have to switch to less than. If the original sign was less than, we would switch to greater than. And if the original sign was greater than or equals, we switch to less than or equals. And if the original sign is less than or equals, we should switch to greater than or equals. So let's dive in. Here's the first example. 3y is greater than or equal to 9. Now the goal is to get y by itself on the left and everything else on the right. So what I want to do here is take this 3y and divide both sides by 3, right? Because what's the opposite of multiplying 3 by y? Well, that would be dividing by 3. And so I'm going to divide both sides by 3. And then these cancel. We just get 1y on my left. And then on my right, we have 9 over 3, which is 3. Notice that here we started with a greater than or equal to sign, and we also ended with a greater than or equal to sign. Now, why is that? Why did we end up with the same sign? It's because we didn't multiply or divide anything negative through our inequality sign. We only divided a positive number. Now, in a lot of pre-algebra classes, especially throughout the different states of the United States, a lot of times they'll also ask you to graph the answer. So I'm also going to show just a brief graphing here. So here I would show from 0, 1, 2, 3, and show that everything greater than or equal to 3 is included. So I'm going to draw a closed circle here because 3 is part of the answer. And then I'm also going to draw a bit of a thicker line to represent everything to the right of 3, right? Everything that's greater than 3 is also included. And so that's what our graph would look like for this one. All right, I still have 3 more examples, so let's get into 3 more. This next one says b plus 7 is greater than 3. So what is the opposite of adding 7 to b? Well, that would be subtracting 7. So I will be subtracting 7 from both sides. If I do that, on my left, I just get b because plus 7 minus 7 cancel each other out, right? They undo each other. And so that's why we chose to subtract 7 to undo the adding of 7. And then on the right side, we have 3 minus 7. Now I'm going to quickly review how do we know what 3 minus 7 is? Well, the thing is, we would do it the same way as 7 minus 3, which would give us 4, except that because we start with 3 and we're subtracting 7, we're subtracting more than we're adding, we're going to be in the negatives. It's going to be negative 4. So therefore, b is greater than negative 4. Now, in this case, we started with a greater than sign. We also ended with a greater than sign as well, because we didn't multiply or divide any negative numbers through our inequality sign. In fact, we didn't multiply or divide at all here. All we did is we subtracted, and that's it. And now I'm going to graph this. There we go. And then I'm going to draw an open circle this time on negative 4 because negative 4 is actually not included. Only things that are strictly greater than negative 4 are included, but negative 4 itself is not included because it's just a greater than sign in this case, not a greater than or equals. And then everything to the right here, I'm going to shade in because all of that is included. All right. Then we'll do example 3. Negative 2x is greater than 10. So for this one, I'm actually going to rewrite this, and then I'm going to divide both sides by negative 2. Now, when I divide both sides by negative 2, I need to flip the inequality sign. So that greater than sign now becomes a less than sign because we divided both sides by a negative number. In this case, it was negative 2. Then I'm going to simplify my left. Negative 2 over negative 2 is just 1, so we just have 1x. And then 10 divided by negative 2 would be negative 5. So we get x is less than negative 5. And then I will graph this as well. So let's say we have so if it's strictly less, not less than or equal, I'm going to draw an open circle because negative 5 is not actually included itself. It's only anything less than it that's included in this one. And then I'm going to shade in anything to the left of it, like that. And there we go. Next, I'm going to move on to example 4. So for example 4, we have y over negative 3 is less than or equal to 4. So in this case, what I'm going to do is I'm going to multiply both sides by negative 3. And when I do that, because I'm multiplying both sides by a negative number, I need to flip this inequality. Originally it was less than or equal. I need it to now be greater than or equal. Now I will simplify, so the negative 3 here and here cancel, and so we get y is greater than or equal to 4 times negative 3. 4 times negative 3 is negative 12. So therefore, y must be greater than or equal to negative 12. Also be drawing a number line here as well. And we know that everything that's greater than or equal is included. So first I'm going to draw a filled in circle on negative 12 because it is included. So we wouldn't do open circle, we do a closed one here. And it's everything greater than and negative 12 itself as well. So I'm going to shade in everything to the right because everything to the right of negative 12 is a number that is greater than it. And there we go. As always, if you have any questions, please leave those down in the comment section, and I'll see you for the next one.